Thank you so much, everybody, for coming. Welcome. This is Open Research Institute's Project Meetup. And what we do is we talk about what we have done, what we have planned to do, if we need any resources, and if we have any roadblocks. So that's the general kind of format of a roundtable meeting. And I'll hand it over to Paul. Uh, Plenty to report there. Maybe a fairly brief lab report because things have been going well for the infrastructure and physical plant of the lab. But you've been working on some things for Opulent Voice. So the floor is yours.
That's right. There's been nothing to report on the lab, actually. So I'll jump right into Opulent Voice. As Michelle just mentioned in the Slack channel, we are in the process of changing the encapsulation method. Uh, the original assumption was that the encapsulation was just to talk from your computer to a modem sitting right next to it, or maybe even internal to it, and that therefore there'd be no problem with network issues. So we chose the simplest possible solution, which was a UDP encapsulation. But now we think we want to be able to communicate over the network, possibly, across the room or across the country, across the planet, um, to a modem that's remote, or maybe not even a modem, just another computer pretending to be a modem for the purposes of using this encapsulation as a way of talking over the internet. And that introduces the possibility of packets arriving out of order or being lost entirely or even being corrupted. Um, so to solve these problems, we use the bigger hammer and switch from UDP to TCP. And TCP, of course, is not the same because it doesn't transmit whole packets as a datagram like UDP does. Instead, it has a notion of a stream of bytes. Every byte is essentially its own little packet from TCP's point of view. They can get mixed and matched and split and rejoined, and all sorts of crazy things can happen. So you have to treat it as a stream of bytes. So we're going to need to add a layer of delimiters to show where the frame boundaries are. That's one way to do it. That's like the best way to do it. You could also do it by just assuming that the beginning of the connection is the zero packet or the zero byte of a frame, and then just count bytes and divide by the number of bytes in a frame, and so on, and use the fixed length packet as your delimiters. But that has some limitations when you start dropping connections and reestablishing them, and so on. So I chose to use delimiters, and that means cobs because we already have all that built in. We can just use it again with another layer of cobs for the encapsulation. Does mean we have to write some code for session maintenance. We get if it drops, we need to bring it back up. Um, Hopefully without too much disruption to the over the air connection.
It's probably worth saying that this is not in the Opulent Voice protocol. So there's no change to the OPV or the headers or any of the layers that are currently there. So it's not adding overhead to our protocol. This is how it's delivered to either an SDR or a remote SDR or computer.
Yeah, that's correct. It's important to note um, because the modem and the computer that the user is running on and talking into probably um, is considered all part of one station from the point of view of the over-the-air interface. So this doesn't affect the over-the-air interface at all. That's the plan anyway, and that's the intention. And I'm just getting started on that. I decided to put the TCP support into my independently developed receiver, which we call postlocator, which is just a receiver for this encapsulation protocol. And I've got connections working, but I haven't got the cobs inserted yet, so I don't have packet processing. But that should be, you never say that, but I predict success in the not infinite future, hopefully the nearby future. And then I'll use the knowledge that I gained by doing that and familiarity renewed with sockets and TCP connections and Python, and input that capability for both send and receive into interlocutor. And there's an additional uh, task there, which we flipped a coin to decide which was the higher priority. And what was the other one? It's been hours and hours, and I've forgotten what the other thing was. Michelle, do you remember?
Yes, this was the problem of so we're not using HTTPS to connect to our either modem or another computer or repeater or whatever the target is, where you want your frames to go from your station. So we make our open or OPV, opulent voice frames, and we send them somewhere. Usually, like to you would think a radio, SER or whatever. Um, if that IP address that you've entered in is localhost, then you have direct access to your microphone using HTTP, which old school, not non-secure or not HTTPS. When you want to use a microphone, then localhost is basically your real only bet here with HTTP. So since we don't want the overhead of HTTPS, we don't think it's a lot. And there's some sneaky ways to try to get around this problem, but how do you get around the problem of not being able to access your microphone directly if you are attaching to a remote SDR? It's a legit thing. We really, really, really want to have a browser interface. It's just a browser, nothing else. You don't have to run any other code if at all possible. Well, we may have to run a small amount of extra code. In order to get around this, if you are localhost, you get the direct access to the microphone and you get to have live audio as we have been doing. That's great. But if you don't have access to the microphone, we may need to run a companion program that takes your microphone and streams it correctly. So, kind of an evasive action rather than trying to fake out HTTPS or implement HTTPS. What does it take to implement HTTPS and give you microphone access no matter what your IP address is? Lots. Like you had then have to be essentially a domain name manager. You have to set up a server. You have to own all this stuff. And that's a lot to ask somebody that just wants to play with their radio. And in order to kind of follow through on the promise of you can connect to our radio system with a web browser, then we have to may make you run a small extra little helper program. So that was the other thing that was a kind of a 50-50. Which one do we focus on first? Either we fix the UDP only delivery method for our frames to the target, or we fix the microphone problem only being available in localhost. Now, it has to be said that efforts here are kind of a step beyond what almost all the other hotspots or digital voice implementations do. All of them, including the big ones, say stick with you. Oh, you're not localhost? No, you don't get a microphone. Or you have to use the actual hardware, the actual HT or radio that you have. So the things that we're confronting here are there are solutions, and we're hoping that they're going to be resilient and good solutions, but they are kind of a step beyond what is currently available in digital voice systems, especially for amateur radio. No other amateur radio system does this, so we want to, and to keep it as light as possible. So it may not be technically possible to stay with HTTP and also not require you to run something in addition or have a little co-program or something that's helping stream your microphone. Anyway, that's the other part of the deal.
Yeah, thank you for reminding me about that and explaining it so well. That one thing that might not have been totally clear is that this is a security limitation from the point of view of the browser, that being able to turn on your microphone and listen to what's happening in your room is considered a high security issue. You don't want people to be able to eavesdrop on you without your explicit permission and cooperation. Um, there's lots of situations where you do want to turn on the microphone. Um, we're not one of the ones that they anticipated, as far as we can tell. There doesn't seem to be an official way around this other than to use a secure connection. And in our estimation, the pain and suffering of installing a little helper program is much smaller than the pain and suffering and difficulty of debug of installing a HTTPS capable server, which is basically what you're talking about here.
Yeah, either
So
that, the only other way that we could think of to get around this was to go to what we've talked about for 5 or 6 years is voice memo. The voice memo approach is an alternative to live audio for long delay channels like geo spacecraft. So if you're uncomfortable with the long delay, then you don't get live audio anyway. Like live audio would be, you have to train to do it, and the delay is a little unsettling. It's a fatiguing thing to do. And so what our another alternative would be just to say, okay, if it's localhost, you get live audio and you get a microphone and it sounds, immediate. And if you're not localhost, then you send a voice memo. So you package up your voice and you send it as a file, essentially. And so that was another thing, but really want to keep the live audio as much as possible so that it is a little more natural so that you can just use it that way. Because the only situation where you would be forced to use the voice memo approach, kind of like WhatsApp, if you've ever used WhatsApp, this is very common on WhatsApp to send a voice memo. The only situation where we would have to use that would be a very long delay channel, like a deep space or geo with additional, with all the latency that would come with it. So that's another way to do it that we might have to do for a spacecraft, but for terrestrial stuff, we should not have to drop back to that. So that was kind of part of the discussions, and this is all in the issues in the issue tracker as well. We tried to make sure that all this content was reflected there, the challenges and the decisions that kind of affect the architecture. So back to you.
Yeah, that's true. We haven't run any experiments in integrating the voice memo with the system yet, but my strong suspicion is that it would be subject to the same problem. That if you don't have a secure connection that's running the JavaScript that's trying to access the microphone, then it won't let you. So even with voice memos, we still need an extra program outside. It would just have a maybe a simpler, easier to implement interface to the satellite system.
Right on. All right. And anything else?
I think that covers everything. We're out having a blast at Comic-Con for several days this week, so progress was reduced.
Ah, Still ended up with a lot of check-ins, so worked out okay. All right, and I know that both I think Matthew has news and Pete has news. So uh, who would like to go first? Okay, Matthew, you have the
All
floor.
right. Um, well, my news is that I haven't been able to get to anything this week, unfortunately. Um, with the new house and everything keeps me busy. So, but I will get there. But it sounds like a lot of good progress is happening. Um, I just was since I hadn't been keeping up, the use case for the UDP was to connect to a well, the UDP was being transferred over the wireless link, right? Was that I think we had
Oh, either wireless or wired or anything, but to go from the whatever's running interlocutor, whatever is collecting
yeah.
your keyboard chat, whatever's collecting your voice, and then to deliver that to the Pluto. So to
Right.
transfer
Okay. So because I mean so the
wire.
UDP packets are being delivered to Pluto, right? That was my understanding.
Yes.
I mean, so I was just curious, could you re-encapsulate the UDP and TCP for that connection? If you say your Pluto was remote, you could just take the same UDP packets and package them in TCP for that path, and then just de-encapsulate the UDPs and send those to Pluto. And
Yes,
that
that would
way,
also work. That would be using UDP instead of COBS in that case for just for its framing capabilities.
right? Well, the COBS is still embedded in the UDP, right?
There's two layers of all this stuff. The stuff going over the air is, the data is encapsulated in RTP, which is encapsulated into UDP, which is encapsulated into IP, which is wrapped in COBS, which is then
Okay.
sent and chopped up into frames and sent up over the air. But those frames communicating to the modem from the local user, local, wherever he may be, um, that's another layer of encapsulation, which is currently UDP.
Okay. So I guess I could see you could just do the TCP. Um, oh, well, so are you sending straight COBS to Pluto or to the modem, or are you sending the UDP to the modem and the UDP is going over the air?
Neither one of those. We're
Okay.
sending we're sending UDP. We're sending opulent voice frames encapsulated currently in UDP and later in TCP from the local computer to the local modem. The modem then strips off that encapsulation, has the contents of the frames, and it will then,
So,
then does the encoding and all the scrambling and everything, and transmits, and
okay, I
then
guess
stops
I'm
it when it
deferring what the
happens.
raw data is to the modem.
Right. Yeah. It's a OPV frame to the modem. The Pluto would get a U or currently gets a UDP datagram. And
Mhm.
then I'm hoping that the Pluto then just goes, oh, look, I've got UDP coming in and pops off the UDP. And then you have our actual OPV frame. So it doesn't have
Okay,
to do anything extra. We want to keep it that way, like to make it as simple as possible. The question was, gosh, should we keep a UDP option for local connections and then have a configuration for the user for remote uses TCP to not get frames out of order? And we're like, oh, you know what? Let's just switch to TCP for everything. This means that the Pluto, which does have a networking port, it speaks Ethernet. So,
right.
you know, so it'll remove all of that stuff in the process of just receiving data from an external source. And then it'll end up with an OPV frame. So nothing extra on top of that. We're trying to keep it, you will get the actual frame that you transmit. So the stuff that goes over the air is the stuff that's in the payload for the that you get at the door.
Okay,
That's it's not
thanks.
intended to be the only way to do it. It's just uh, a way to interface the local computer to the local modem if the local modem doesn't have a lot of handy I/O. If you were running inside the modem because you had a more powerful processor inside the modem, you wouldn't use this interface. Use some kind of high-speed local interface that is low overhead,
Yeah,
um, like you maybe have GPIOs or something.
yeah,
Um, but here for the Pluto, the only effective interface it has without hardware mods is this USB connection, which can support an Ethernet.
Right. Okay. For
yeah,
some reason, I thought in our discussions before we were sending IP packets over the air so that you could effectively connect to another machine and then, or you could route to the Pluto or to the modem, would go over the air and then connect to a network on the other side, and you kind of get end-to-end connectivity.
That's
Um,
still the case.
oh, it's still okay.
yeah.
The packets that we're delivering to the modem, I'm just talking about the transmit side because it's easier. The
You're right.
packets that we deliver to the modem contain the whole protocol stack, IP, and then if it's voice, it's going to be UDP and RTP and voice data. But if it's text messages, then that's UDP and text messages, and control messages, UDP and control messages. But there's also IP and whatever. And those probably might take up multiple frames, might take up only a tiny fraction of a frame, depending on how big the data is. But, well, not that tiny, because this is a lot of overhead. But we still have the full capability to handle arbitrary data. And that would, instead of being handled in the program, interlocutor in this case, it would be just dumped into the host computer's network stack and routed, and you'd have all the full functionality.
Yeah, which
Okay.
we've seen early indications that this is kind of nice because I took my cell phone and I connected to Interlocutor and I was running the interface from my phone and it rendered great with the HTML5, framework. I'm not a a web developer in any way. So this is a fairly simple and following like accessibility standards and all that, but that resized for a mobile, and I was able to do stuff with it because of the extra protocol layers. So early indications are, wow, okay, so all of this really does work, and the more we will try all sorts of applications and to see how it plays well with other applications. So that's kind of we're starting to see the potential realized. So that's the stuff that goes out over the air. What we want to do is to deliver to the modem. Here's the frame. Like, the modem doesn't have to do any extra management of a bunch of extra layers that got it there. So whatever it takes to get it there in the right order, delivered correctly, that the networking stack or protocol stack on the networking functions of the Pluto, since it's a network accessible SDR, all that works without you having to change anything in the code, that the modem code just gets what it needs. And you reminded me that we had streaming working first, and that's what I'm going to try as soon as yeah, as soon as I can, find the universe with my fingers, that we we'll try it. We'll say, okay, here I'm sending you. I have this connection. It's up and running, and all that TCP stuff is working, and then the data is coming from there. And the streaming part, cross your fingers, should deliver it to the modem and go out over the air, and we should see the MSK, and the reverse should work. So, as a raging optimist, hey, we're super close, right? So, odds are there's going to be something that we did that does not play well with the modem, that there will need to be a change in the HDL. But yeah, that streaming stuff from the original examples from Analog Devices, I'm going to leverage all of that and try to, because it should work. I think that we're really pretty close to having an actual end-to-end over-the-air demo. Right now, end-to-end demos are working great in the lab, over LAN and over larger connections, over more remote. As soon as we go to TCP, I can actually get somebody to install this program on their computer in Seattle, and we can try it out over the internet. And then we can start moving to maybe hosting a repeater or server on openresearch.institute website, so people can try it out and see how the user interface feels. And then we just keep stepping forward and keep moving forward with adding all the different functions, and then it's over the air. So that's the goal. We're getting a whole lot closer with all of that. So yeah, I'm going to take your advice and go uncomment out all that streaming stuff and see what happens, what comes out the other side. We'll probably need some help there, though. Um, the streaming is pretty simplistic from the example from Analog Devices that we had working. Um, I think Paul had some opinions about the way it was set up and called and everything, but we now know a whole lot more than we did before. So I think we're pretty close.
Great.
Yeah, we've shown that locally generated data can be streamed indefinitely with essentially zero error rate by just transmitting some moving sine waves, and they work. That's going in to the fabric through DMA, which is basically the same as streaming. This should be a one small step for mankind from there to getting it streamed over the network interface.
Yeah, Should is doing a lot of work there. So we'll have lots of good stories, I'm sure, for when we meet next.
Yeah.
So yeah, anything else, Matthew?
No, I don't think I have anything else.
Okay. All right. Pete, you got the floor.
Okay, so from OPV to Eve, which only has a couple of bits instead of all that nice multimedia. But here's where we are. So we did that big link budget back a couple months ago, and the really useful output there was we got carrier power to noise density, right? So the thinking going ahead was if we pick, any given low bit rate, we can convert that to an EBNO, the energy per bit on noise density. And then we could do some trades on which modulations work better or worse. Look at the bit error rate and see what we could do. So the first one jumped out, looks a lot like signals we already use for like whisper and moon bounce and stuff, which is to use M-ary orthogonal FSK and see what it can do. And the cool thing about it is if you bump up the M-ary, the bit error rate goes down for a fixed EBNO. So that seemed pretty neat. But then the wrinkle is our coherence time is pretty short. It's a quarter to a half second for Eve. It's similar for Moonbounce. And so then when you do the non-coherent combinations, what happens is for a fixed bit rate, when you have more bits per symbol, the symbol period gets longer. And so it becomes longer than the channel coherence time. And then you have to non-coherently average, and that's less energy efficient. So it erodes a bunch of the benefit. And I did simulations. It looks like the M-ary orthogonal for us has a pretty narrow range of performance despite M-ary. Like low M-ary and high M-ary are probably pretty close in the bit rate we can get for our setup. So that may just be how it is. Maybe that really is how it is. But as another thing, since we're not under too much time pressure, I'm going to look at if we could use different modulations, like variations of transmit reference spread spectrum, where that you can have a symbol period that's much longer than a channel coherence time. And maybe if not OTFS directly, maybe some low tech adaptations of OTFS. You're not touching not having transmitter knowledge of the channel or that stuff. We've relegated that one to moon bounce at best, and are bannering about trying to figure out if that even can be done. So anyway, over here it looks like that we're getting bookends on M-area orthogonal in any case, and they're probably pretty tight bounds regardless of what we pick. And then we'll just see if one or two of these other ones from like an old Sklar paper was one of the inspirations. If they can do any better, and then we'll sort of know where we are. And the end goal is just to figure out how many bits per hour are we getting. But my optimism's going down, and it may literally only be like a dozen or something. So we'll see. That's it. Oh, the other thing was I saw Paul had Hello Kitty in his background, and my local mascot is Marvin the Martian. So.
Right on for Marvin. Very good. Yeah, we name our servers in Remote Lab West after Hello Kitty's friends. So there, if you wondered why we have a server named Karapi and Choco Cat and Karami, then that's why. And I haven't run out of them yet. There are plenty more friends to go. So anybody that would like to spin up a server and do some experiments, then your future might be cinnamon roll. You never know. And Marvin the Martian, that's I don't know. Gosh, I think what a great reason to start a new lab is because of such a great character and all of Marvin's friends. Very good. All right. Any other project updates? We do have DEF CON coming up. We have a July newsletter coming out very soon. So we try very hard to get it out at the end of the month. We're at 20 pages and counting. So there's a large, well, I say large, multi-page article about the next big step for Opulent Voice and Hyperion, which is to add the conference server. So we've been talking about Opulent Voice as the uplink. The next kind of big phase of development and demonstration is to show how conferences work, that you join a conference, you can search for a conference, you can find a group of like-minded people talking about Python or Hello Kitty or D&D or whatever, and that you can join the conference from Interlocutor. And so there's some state that would have to be managed in the satellite. That's my assertion. And Paul has a slightly different view. He is very motivated to reduce state at every possibility to keep it as simple as possible. So we think we have hammered out a pretty good way of sort of handling a roster of conferences that you can join and who is in those conferences. The only thing that really gets you to join a conference is a transmission. So if you see a conference and you want to monitor it, you can. You can listen to anything on the repeater or satellite that you want to. You can listen to all conversations. That's a sort of an amateur radio thing, right? If you want to participate or join a conference, then you target that conference and you transmit to it. And now your call sign or station ID is listed as the members of that conference. But you can still filter and listen on any of them. If you don't transmit for a while, your call sign drops off. If the conference itself is inactive for a while, it drops off the list. So it's kind of self-cleaning so that you don't show up and see a whole bunch of different rooms or conferences and they're all empty. We do not want that experience. And so that's kind of the next sort of big development push on the user interface or user experience side is to bring up the conference functions. So right now we have two tabs in Interlocutor. One is the communications tab. That is your message history, where you see your audio replay, where you hear it in your headphones, where you type on the keyboard chat, where you see evidence of the control messages coming and going. The second tab is a configuration tab. This is where you build your configuration file, which has your station ID, has the target IP address, has all of the things that you can configure for your particular station. We make it as easy as possible, from the most common things at the top down to the least common things that you would want to change at the bottom. We'll need a third tab. So anytime that your radio, your interlocutor hears a broadcast message of, hey, guess what? I'm a repeater, or hey, you're in range of a satellite, and here are all the conferences that you can join. Then that tab populates with the conferences. You can search for one. You can say, I would like to target that one, and your next transmission will then join you automatically, and it'll switch your tab back to the communications tab. So I tried to write up a sort of a high level design document. I put it in the Opulent Voice channel. Um, Feedback, comment, critique, beat it up, what's missing, what's not. Now's a great time to weigh in on that. Anyway, that's the next kind of phase for Interlocutor. We're reasonably happy with the way that the communications tab is working. The voice quality is really great, and the replays are really nice. Another thing we're looking at doing is to add transcription. So if you can't hear, then the audio stuff needs to be accessible to you, and you should be able to get a transcription of any of the recorded audio. And that can either be done in a separate WebSocket. That's a common way to do transcriptions, is to have it in a separate WebSocket that you then have in a completely different page if you want. Paul recommended, and what I've heard people want, is some sort of little indicator on the UI bubble for the recorded audio. So you can either hit play and hear it again, or hit T and get a transcription in the window along with all, so it just looks like another text message. We'll see. Both and rather than either or is the recommendation for general accessibility. So those things will be moving forward, probably not until after DEF CON, which is coming right up. We'll have a table, an exhibit, open source digital radio exhibit in RF Village, and we'll have Ribbit being demonstrated. That's the plan. Ed Friesma, who's going to come and bring all sorts of interesting radar stuff. So radar, you can do DIY radar and like the Cantenna based radar, and he's going to talk about synthetic aperture radar, and he's going to be at the booth. Me, Paul, Lab Tech One will all be there, and anybody else is welcome to come and just staff the booth or come by, drop by, and see how we're doing and talk about things. We should have the hard hat brigade there, so they're going to show off their hard hats, a lot of which has RF stuff in it. There's a CTF going on, so tons of things going on in RF Village. That'll be in early August. Right before that is the FCC TAC meeting. We delivered our chapter 2 of the final report for TAC this year. It has not had a sort of a final approval from the FCC yet. So in the next newsletter, there will be just a kind of a high level summary of what we said about future dynamic spectrum sharing models and where things are going. We tried to work in and emphasize regulatory issues for amateur radio, for both the satellite service in general as a model of working for decades, terrestrial and satellite, cohabitation and sharing. And we emphasize that you do not need fancy AI or ML to successfully do sharing between terrestrial and satellite, but it takes some ingredients that industry may or may not have. So we discussed that. We talked about the 219 megahertz regulatory renovations that we kind of pointed out. We're pointing this out as sort of a regulatory failure because even though we have access to this band and privileges on this band, no one has activated it and no one's been active on it for a while. And it's because of regulatory decisions that were made decades ago. So we highlight that as this is evidence of a change that's needed in the sort of the regulatory approach. So amateur radio actually did feature in chapter 2 quite a bit for the charter 2. So as soon as that's finalized, we'll then publish our chapter in full. Until then, we can only give like sort of a high level summary of it because it's just a draft and not yet approved by the FCC. That'll happen on August 5th. Let's see. I have on the agenda, I have Hyperia receiver on the to-do list. We really do need to start paying more attention to the receiver side of the satellite. We did have a lot of work there done by Ken Easton, and he still wants to do it. His new job is taking up a whole heck of a lot of his time. And this is really leveraging another open source project's work, Theseus course, which fit right in. And we just had to make some minor changes to this. It's a multi-rate channelizer. So for all of these Opulent Voice channels, FDMA going up, something needs to catch them. And this multi-rate approach is really good, very efficient. It's Not yet to like a prototype stage though. Like everything kind of worked and we were able to run some basic data through and show that the design was working from like within FPGA. It's not yet as mature as it really needs to be. So very soon we are going to be showing up with uplinks that have data that work, and we need something to catch it. This FDMA system needs to be working. So that's going to very soon be an area of interest. And I'm talking to 3 or 4 different people who are interested in this sort of work, but all of them are a little intimidated by it too. It's a lot of math, heavy DSP, polyphase or multi-rate processing does take a learning curve. And anyway, that's going to be an area over the next couple of months that we really are going to need to start paying more attention to. Good work's been done. There's some repositories, there's some papers, there's some diagrams, we have an understanding, we know that this is the right way forward, but we don't have working code. So that's going to soon become the short pole, I guess, and we need to kind of keep that in mind.
I'll just throw out that I understand polyphase channelizers really well. I
Oh,
mean, maybe
cool.
too well. Maybe it's so mathematical, everyone else will just laugh at me. But no, I understand them on a real fundamental level, and I could probably help there if it's helpful.
Okay,
Um,
good. Yeah,
Willing to give it a go if everyone else is.
okay, we'll talk a lot more then because that is going to be like I'm looking out on the I have to admit I don't really look very far out on the horizon because there's so much that is immediate that needs to be done. But I can, even me with my limited vision for future prediction, that's going to be our next big thing. That's going to be the part that's the most ricketyest. You know, we knew that Opulent Voice, that the uplink was just on paper, that it was just kind of not even really vaporware, and we now it's not vaporware. It's actually a great demo. So, you just need to pick the thing that's the next weakest part. And pretty soon, something that had a lot of good work on it will be the weakest part because it doesn't have a working prototype in the lab. So we will definitely talk. It won't be for a number of weeks yet. Uh, but thank you. And yeah, I'll be definitely reaching out and trying to put together a team for that. Because I
It's the
suspect.
big picture. You come up with this channelizer, and then you have a bunch of instantiations of Matthew's DMod behind it, and that's how it all works.
Yes.
Okay, doke.
At
Sounds
least
good.
that's my very basic, naive sort of way of looking at it. There's a number of ways to do it, as you know. Either you instantiate individual receivers across the board, or you bit slice around and you just really have one, but you're operating at a higher frequency, or you know, it looks sort of look like a tree. So it's a balance between like how much time do you have, how much logic do you have, do we need to go get a bigger FPGA, that sort of thing. So that sort of floor planning has not yet been done, but we know that we can brute force it by just okay, we'll have 96 of Matthew's designs, and there you go, or 4 or 8 or 16 or whatever it takes to get a proof of concept. And the multiplexing side, like, okay, now you've got all of this, and now we've got a stream of things. We know what the content is because we know the port number, we know that this is chat, and we know this is that. And then that plus the conference server organization, like, oh, all of these call signs go there. They all have this conference tag, and it just all goes into the downlink. And if there is any multiplexing other than, adaptive coding and modulation from DVB-S2, we'll do it, but the lightest touch possible to get everything, multiplexed into the DVB-S2 downlink, add just enough to make it delightful to use it and to find communities of interest. That's kind of the goal. And that multiplexing stuff, that exists only on paper. That we understand that that's what we're going to do, and we know that we can do it, but there's no demo other than in MATLAB. Let's see. The next thing I have is the open source CubeSat workshop. This is a Libre Space Foundation. If you're not familiar with Libre Space Foundation, you should be. They're remarkably amazing. They were the ones that designed and implemented and brought us SatNogs. This is a distributed satellite receiver network worldwide, hundreds of stations. free and open source the whole way. It's networked, and the entire database is there for you to go look at. So if you would like to see, on the satellite bands, what's going on, SatNogs is should be number one on your list. So LibreSpace Foundation, a number of years ago, had what was called an open source CubeSat workshop, and I went to the one that was in Madrid, Spain, at ESA. It was an incredible experience. It was great. This next one coming up in October is in Greece, which is where LibreSpace Foundation is headquartered. So they're from Greece. And this looks like an amazing event. So we actually did not submit anything before the previous deadline, but they've extended their submission deadline. And that's good news because it's now out into August, a little bit past DEF CON. So I was thinking maybe we could submit something about our work. The space related stuff is pretty strong, and we by October we would have an even better demo than we do today. So we might actually go ahead and submit now that the deadline's been extended. But anyway, we will absolutely be attending remotely because the Greece is kind of a long haul. I don't plan on going in person. And the attendance is limited to 200 people in the facility that they have in Greece. So not a huge conference, but a workshop. And really, really good experience. So looking forward to seeing all the talks. In the past, they have published the recordings of all of their talks. They organize it in lightning talks. So the talks are very short. On site, there are some longer sort of meetups and roundtables and workshops. I don't think that those are normally recorded and published later. But if you go back and look at previous open source CubeSat workshops, good stuff, and going to be great this time around. What we will be attending in person is the September ESA and AMSAT DL symposium, and that's in September. And we will be presenting about all the stuff that we want to contribute towards the Future Geo project, which is an initiative from ESA, and AMSAT DL has been selected as their main organizer of the amateur radio community. So AMSAT DL asked us to kind of like, hey, let's hear what you have to say. Do you want to commit to being part of this? And we talked about it, said yes, and our response to the survey questions that they sent to us will be in the July newsletter. So the full response of what we sent to them will be printed there so that folks can see what we said that we could do. So yeah, that's exciting stuff. And that's it. That's all I got on the agenda list. And I'd like to open the floor for any last comments or questions or any sort of like what I've done over the past week or what I have planned over the next week, like anything at all.
Well, I'll say one thing. We originally conceived Opulent Voice as being associated with this high orbit satellite project with a big fat pipe shared downlink. And that's very cool. And there's lots of things you can do with that. But we also want to be able to use it on a peer-to-peer basis, which means that the downlink is just as slow as the uplink. And we need to spend some time at some point defining what the subset of features is for that. It may be as simple as, like FM repeater emulation, but hopefully it'll be a little bit nicer than that. We'll be able to handle the text messages and data along with the voice. It's not a super fast data channel, but sure is better than nothing. Faster than packet radio at 1200 baud by a lot. So we need to, that's another task on the list of things to do is figure out exactly what the subset is for peer-to-peer.
So probably wouldn't feel a lot different from the way that it is right now in the lab, where I directly connect to you, you directly connect to me. In the message history window, I'm seeing your replay audio, I'm hearing you typing to you. That's pretty symmetric right there. It's just I send to you, you send to me. It's half duplex. It could actually go over a FM repeater, at least for you on UHF, probably not on VHF, but it could go over a repeater today.
Well, if you had one that had the bandwidth, which they don't.
Yeah, most don't. That's true. That's something that I've had to clarify to several people who are very interested in incorporating this into hotspots is that, so they're set up for essentially narrowband FM, and that's not us. were wider than that. So I have had to explain that the bandwidth's a little wider than you think. And I mean, with the rules, it works, but we may have to figure out cheap and easy way for people to actually get the hardware. Because to me, like buy a Pluto, buy a Raspberry Pi, download the software, there you go. That's still hundreds of dollars, really. I mean, a Pluto is not two digits, it's three digits of US dollars. And a Raspberry Pi 5, which is what we're using now, we've used a 4 and we've used a 5. The 5 is better performance for the web interface. So, what's the cost of a Raspberry Pi 5 right now? So add that to your Pluto, and that's the cost of a station. That's a complete station that can do all sorts of stuff, for your ground station. I mean, but then and I think it still can receive the full uh, DVB-S2 as well, but can it do both at the same time? I think so, but
I don't
that's
know that I may not have to include the Raspberry Pi as part of the zero cost or low cost station because everybody's got a fa computer that's way faster than a Raspberry Pi.
true.
Most of what the Raspberry Pi can do is perfectly adaptable to your laptop.
Yeah, that's true. I'm stuck on the Raspberry Pi because that's what we're targeting. So if it works on a Raspberry Pi, it'll work on almost anything, and that keeps us honest.
Yeah.
But true, so
But
you'll need
one,
like a radio, but to the Pluto intended as an educational tool, intended as a prototyping tool. This is a step towards an end product, some sort of open source hardware thing, which if we do it right would be inexpensive, would be as cheap as we could possibly get it, simplified sort of radio. So that's in the cards, further out than anything we talked about today, but that's on the path, is to get us there to where you can have the software. Software's totally free. Uh, Put it on as uh, many different computers as possible, and as long as you have a radio or a target that has an IP address that can understand frames delivered with TCP, then you have your data stream. You've got it. So we're trying to make it as easily deployable as possible. And I think these are good choices. We'll just have to try to make it make it work, to make it demo well, and then make it extend and scale well.
yeah, the peer-to-peer mode will be a little bit more elaborate than what we got here in the lab because limited to two terminals basically because of the way we're just transmitting packets directly to the other station. But if we had a broadcast medium like a radio, then it could be small group conversations, just one person talking at the same time because you would have no way to receive more than one uh, up 16 kilobit voice. But that's not that severe limitation. It's a similar limitation to what you have on an FM repeater. Only one person can talk at a time.
Yeah, or a simplex conversation where everybody's transmitting on the same frequency. That's pretty much what it is.
Yeah.
So I think we're
Hopefully
good.
they're all within range of each other. And you start to get into hidden terminal problems if you don't have that.
Oh no, the hidden terminal problem. Somebody wrote a paper about that, I think.
More than one person that written
Yeah.
papers about that.
Oh boy, yes. Well, I think we have something from Matthew as well. He has some news to share.
Yeah. So uh, Michelle's very kindly had nominated me for the ARRL Technical Innovation Award, and just got a call from them last week, and they've given me the award. So I think that was very much appreciated, and we'll see how that comes along. But anyways, I thank you very much, and it's pretty cool. Thank you.
You're very welcome. Well deserved. Thank you so much for both the innovations that you've delivered that we could not do any of this without, and the excellent leadership, and very clear communications on the modem module approach. I think that it's already paid off for us, and hopefully will pay off for plenty of others in the future. And yeah, I look forward to hearing about where you accept the award, uh, and the cool plaque that you get, and just a big time congratulations. Well deserved.
Thank you.
All right. Well, thank you, everybody. Your time cannot be replaced once you spend it. So when you spend it with us, it's deeply appreciated. Thank you so much to everybody for coming. Thank you, everybody, and see you on Slack.